Hey folks, I'm Mr. Hartzler and I wanted to talk to you about law of sines. And with law of sines, we're actually going to start off by creating this formula or this law. And it starts off by using a triangle. So let me share my screen with you. Let's start off with this triangle. And I do want to say just from the beginning that with law of sines, you do not need right triangles anymore. So this is the first time we don't need right triangles, which is kind of exciting. We could do it with more things. All right, so I have this triangle here. Capital letters are angles and lowercase letters are side lengths. I do my capital letter C, just a little tag at the top there just to help denote it as capital. All right, so first thing I'm going to do is I'm going to solve or try and find x here. So sine of angle A is equal to, well, right, opposite over hypotenuse. So x is going to be over lowercase c. Let's do the same thing for angle C. Let's find sine of angle C equals opposite, so still x, over hypotenuse, which is A. Now, x in both of these is the exact same side, so let me solve for that. So on the left one, I need to multiply by C. On the right, and on the left side, multiply by C. So now C sine A equals x. And on the right side, I'm going to multiply by A. So now A sine C equals x. So now I'm going to utilize the transitive property, or I have something that equals x, and I have another thing that equals x. Those two things must also be equal to each other. Transitive property. It's sweet. So C sine A equals then A sine C. Let me divide both sides by C and A. On the left side of this equation, the C's cancel. I'm left with sine A over A. On the right side, the A's cancel. I'm left with sine C over C. Let's write that out. Sine A over its side length A equals sine C over its side length C. That's awesome, right? I can do this with more things, and if by a similar process there, I can find out that sine of angle B is going to equal or divide by side length B. And all of these things are going to be equal if I keep referencing that x, right? It's awesome. So this is law of sines. It's pretty cool. Again, you don't have to have right triangles to make this work for you. That's the really nice thing about it. So if you do not have a right triangle, then you can't use SOHCAHTOA. So instead, you have to use law of sines or law of cosines, as we'll see later. So let us actually use law of sines now to do some stuff. Clear all of these, and let us start with an example. So let me tell you that I have triangle MNO. Let me change it to black because I think that'll be easier for us. Just draw a triangle, not a right triangle, and let's give it M, N, as a capital N, and O. Okay, so these are our sides, our angles, I mean, so this then is side N, this one is M, and this one is O. Okay, I do know some of this information. I know that this angle, M, is 135. I know that its side length is 18. Yeah. I know that N equals 14, and I want to actually find the measure of angle 0. Okay, that is my end goal. That's what I want to try and find. First thing I'm going to do is set up all of these as ratios. So that's going to be sine M over M, sine N over N, and sine O over O. Okay. This is going, when I now substitute in the numbers, I have 135 over 18. Awesome. I don't know angle N, but I know side length N, and I don't know anything for O. Now is where I look at this. Do I have a completed ratio? Later, if we don't have a completed ratio, we have to do law of cosines. But I do. I have the M's. I have both of the M's here. So I'm going to kind of highlight that, I guess, in red. That I have both things. I can figure out what that number is explicitly. So let us do that. And sine of 135, you can have that as a memorized value, or you can type that into a calculator. And I know that that's going to be sine of 135 is going to be equal to a square root of 2 square root of 2 over 2. But in this case, I think it's going to be easier to have that as a decimal equivalent. So I'm actually going to type that into my calculator. Make sure that your calculator is in degrees, otherwise you're going to end up with a headache later because you're not going to get what I'm going to get. All right, so that ends up being 0.7071 divided by 18. And that gets me 0.0393. That is what I'm going to use instead of sine 135 over 18, just so you're all aware. So I'm actually going to now set that equal to sine n over 14, because there's only one missing variable there. If I were to use O's, there's two missing variables, can't find anything. So 0.0393 equals, let me change colors, sine n over 14. Let's solve for n. I'm going to start off by multiplying by 14 on both sides. Put my calculator, multiply by 14. Oh, cool. So that gets me 0.54. And then this is actually going to round up to, let me erase that, 55. 0.5500 is what that rounds up to, so that's kind of cool, equals sine of angle n. In one of my previous videos, we talked a little bit about inverse functions. So now I actually have to use the inverse for sine to find out what this angle is going to be. So that's sine to the -1. For my calculator, I'm going to hit the second button, then sine. And second button, then sine of that 0.5500, or in my calculator, it's 549971, blah, 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 33. N equals 33 points, there's the dot, 365. That is my angle measure for number n, or letter n, sorry. I'm actually going to have to use this to find my missing angle. 33365. The problem before is I know nothing of m. I need to know at least one thing of m or of o. Sorry, I need to know one thing of o to find the other o. So let me erase some of what I have up on here now. Let me erase all of this. Yeah, I'm going to just erase that. And now I know some more of these things, right? I'm going to go off of my original one. So this is 0.0393. I'm going to set that equal to the O stuff now. Sine O over O. But I can figure out what that angle is, right? 180 minus those other two angles is going to get me my missing one. So let's do that. 180 minus that 33 angle minus 135. I end up with 11 degrees. So instead of O, I'm going to write 11.635. And now what is sine of 11.635? So sine of that number is a decimal again. So 0.0393 equals 0.2017 over, and that again, it's the letter O. So I'm going to do like just a weird little stick off of it. Okay, that's a letter O. It's a variable for us. Okay, hopefully you're with me so far. If not, walk through that one more time. Again, I found my missing angle of 11.635 degrees by subtracting the other two from 180. You've done that before. That's classic solving for the missing angle in a triangle. Now I need to find out what angle O is. So this is where actually you could cross multiply and divide, but instead, that's what I'm going to do. So I'm going to multiply by O, and then divide by this 0.0393, divide by 0.0393. So again, that's my O is now going to equal 0.2017 over that other thing. And that gets me, oh, what does that get me? divided by. Let me try and go up and find that actual number so I can get this as exact as possible. That tells me my side length is 5.1338. That is exciting. I know it was a lot of work to find just one little side length, but kind of feels good. Oh, actually, we didn't even need that part. It was just looking for the angle. Oh, that's my bad. We could have stopped a little bit ago, but there's that. Cool. Save this, and let's do another. All right, so if that one suited you well, then you can probably stop watching me. So let's look at triangle ABC. Let's make this triangle. And let's say that this is A, B, and C. So this one is 60 degrees. Side length A is 8. Side length B is 6. And we want to find out angle B. Awesome. Let me set up these ratios. So I have sine A over A equals sine B over B. But I know a lot of these values, right? I know that this is going to be sine 60 over 8 is going to equal sine of, I don't know, over 6. Now, what is sine of 60 divided by 8? Those are all numbers. Let's plug that in. Sine of 60, end my parenthesis, divided by 8. That gets me 0.1083. That's going to equal sine B over 6. Now, let's solve for B a little bit. So we're going to multiply by 6, multiply by 6, multiply by 6 in my calculator. I end up with 0.6495 equal sine B. This is where we use our inverse function. So now, sine to the -1, or inverse, of that number, 6495, there we go, is going to equal my angle. So I'm going to hit the second button, sine, and then I'm going to type that number in for my calculator, and I end up with, there we go, 40.505 degrees. Awesome sauce. Woo! That one was a little bit easier, right? Definitely check this one out and then go back and rewatch the last one. All right, so I hope this was helpful. And again, if you don't have one completed ratio, like this was my completed ratio this time. If you don't have that, then you have to use law of sines. If you don't have that, let me stop sharing here. If you don't have a completed ratio, then you have to use law of cosines, and that's in my next video, so check that out. Have a phenomenal day, everybody. Click that like button down below, and please subscribe to the channel so you can see more of this. And if you comment, you can tell me good things and bad things. I can take some criticism, right? Let me know what I need to do to make this video more clear for you, and so that you can learn better from this. So I know everybody learns differently, and I need to know how you learn, right? Give me some tips, give me some pointers so I can make a better video for you. Have a phenomenal day. I appreciate you watching, and I hope you enjoyed it. Bye.